and gentlemen, thank you very much for giving me voice. I will today about trial of Professor uh, Aki from Saudi Arabia, Aki Ahmad from uh, from Chemistry College of Science in Al Khairi in Saudi Arabia. The winner is sure the trial was to check if wastewater from potato waste, as example vegetable waste water, can be used for can be utilized by microbial fuel cells. Their work was published in Biomass and Bioconversion and Biorefinery, and the work is recently published and is saying reversion as if potato waste, sweet potato waste, which are big industry in food, uh, feed in food production in Saudi Arabia, can be then used as source of electricity. And the idea wasn't to check which gases forms during splitting, but only how much generated. The work that the microbial fuel cell was put into wastewater was put into the 700 milliliters reactor with electrode, with cathode, and in electrode was bacteria, pseudomonas, and the other was collected was was graphite electrode cathode, and this was given us for 15 days, and sweet potato were put with addition of chromium and nitrogen, carbon, cobalt, and copper. As usual, mixed trouble of waste in Saudi Arabia, so can be also some mixed with other wastewater, char, and was mixed with 0.5 kilogram potato waste, was extracted to 15 days. Then it's important to check how can be much energy can be given. The pH was from 4 to 10. Initially it's 4 and then going to 10 by sodium hydroxide. And the DAS was, however, was for 15-day plants. The is required for 125 days. The voltage produced was 154 megavolts. The trouble was that this counter give high resistance, so the big trouble that in this circuit voltage we have uh, uh, much current loss. So the trouble the wasn't so we need to change. They need to change such circuit in future to make less, because the resistance was even 1000 omegas, and um, this trying to reach by checking, by providing uh, lower energy efficiency optimally of 0.85 megavolts per meter squared. It's not very high, but simple to work for 15 days. The and during time the resistance was growing, so conductivity was the optimal in first 10 days. Then conductivity was losing with increase of resistance, and this shows well what is that can be used these ways for current producing, but they don't check how if gases from what gases are. Just the idea was to check whether it can be used to as energy source to current voltage, and it shows that it can. pH demonstrating effects upper was 4 to 7. Then after 10 to 15 days, rapidly going to 7. However, trying to to to, to give 10 by sodium and at 4. However, in the 7 was thinking to catch, but still was removal and efficiency of metal ions was highest as pH 7, but the lowest was in case of the production. So if we want to remove metal ions by this circuit, we should control, and pH 7 is optimal. But for voltage and current using, they used the they used is sweet potato waste. They also checked to compare with only commercial glucose, and commercial glucose produced much less voltage, and removal was also much lower than in case of potato. So they give the solution that we can use mix vegetables and ions with microbial fuel cell to remove these metal ions, and but the removal of metal ions is not high production removal, is not necessarily connected with high potential, and with the pH which is going to make the highest voltage production, but mediocre. So we need to find what is the aim of more to reduce or more to produce energy, and was metal ions was 90%, and in this case with the highest pH, the reduction was 70%. So was quite very efficient to remove, but it should be also in this research check what gases production could be. But I think that will in the future will research and will make. So thank you very much for listening.